Good evening, everybody. Tonight is lesson 9 of Lambda School's Mini Bootcamp. My name is Deandra Ryan Moss, and I am your instructor. So just in case anyone is joining us for the first time, let me tell you a little bit about Lambda School and about this bootcamp. So Lambda School itself is a computer science and web development immersive. So we teach you everything you need to know about web development, back-end, front-end, design to API, the entire stack of what you need to build web apps. And then in addition to that, we also teach computer science topics such as object-oriented programming and some data science topics using Python algorithms, things like that. So it's a really cool course. It's 6 months long if you're full-time. We also do offer a year-long part-time if you wanted to take it in the evening. And one of the things that's really great about Lambda School is that it's de-risked education. So what that means is that you don't have to pay anything up front. We will take on that risk for you. So you can either sign up to pay back your tuition your first year of working or your first 2 years of working. So what that means is we only get paid if you get a full-time computer science job making 50K or more. So it is in our court to try to make sure that you get the job that you want. So one thing that people wonder about Lambda School is what languages specifically are you going to be learning in this? And we do focus largely on JavaScript, which is the primary language of web development. We do front-end frameworks, back-end frameworks, so full stack JavaScript development. And then we do also go into C and Python so that you can be a little more well-rounded, a little versatile, and understand some of the more computer science-y sides of programming instead of just web development. So Lambda School is great. We have a class starting in just a couple weeks, I believe. So if you're interested, get on it, apply as soon as possible. And if you're interested in starting a little later, we start one every single month. So definitely reach out and apply. As far as this mini boot camp, this is a 3-week course that we offer totally free to try to get people who are interested in our main curriculum ready and to just offer some knowledge to anyone who wants to learn a little bit more about programming. So we're now on week 3. We're starting to get into the thick of things. If you are new to this, I would definitely go back and check out some of the classes that are all up on YouTube. If you're totally new to JavaScript, it might be rough to jump in on this one, but you're welcome to stay and hang out if you've been with us. Thanks for sticking around. I hope you guys are all also hanging out in Slack and you're all going to post any questions you have throughout this lecture. So let's go ahead and jump on in. Tonight we're doing even more JavaScript. In line with the last few lectures, things are just getting deeper and deeper. So get ready to learn some more fun advanced JavaScript topics. Let me go ahead and share my screen, and then we can jump in and do some coding. Okay, so let's start by doing a quick review of last Thursday. So last Thursday, we talked about writing classes. So up on the screen, I have these 3 objects, and they're all types of assassins. They all have these assassin-related properties, such as their codename, weapon, etc. And they all have a method on them called kill. And what we saw last week is that when you find yourself writing, 3 sets of code like this where there's a pattern and you're repeating yourself a ton, that's not good practice. And there's almost always a better way. And in this case, the better way is classes. So classes are a way of creating a new type of JavaScript object that follows some certain pattern. So instead of having these 3 different assassin objects, we could create a class for just a general assassin. So, and as I mentioned, you always capitalize the name of a class variable. And that's just convention. So inside of this, we have the keyword this available to us. So we can create this.codename, this.weapon, this.stealthy, this.headcount. And then we can assign these either based on input or based on default values. So for this, we want the input of the actual code name, the weapon, and the stealth value, because these things are going to be variable. They're going to change depending on which type of assassin we're creating. We can go ahead and assign them. And then in the case of our head count, which we want to just always start at a default of 0, we can go ahead and hard code that in. So now when we create an assassin using the keyword new, see, who should we create? So instead of hard coding everything out, we can create our ninja assassin. And we use the new keyword. We call our assassin constructor, and we can go ahead and throw in all of those custom values, the code name, the weapon, and the stealth value. And of course, we also want to make sure that we have our kill function, our kill method attached. And if you guys recall, the best way to do that is to actually put it directly on the prototype. The prototype is an object that is automatically created on any class variable, and it's kind of almost a library it's a collective place where any methods that would be shared throughout all of these can live. So we can go ahead and just write our function on the prototype. And let me move this all up. So now our ninja assassin friend, better comment out our last one. Good thing const is doing its job. There we go. So now we see that we've managed to create our ninja assassin. We don't actually see that kill method, but it is there because it's hiding out of sight on the prototype. So if we run it and then log out our assassin again, our head count goes up. So just in review, that is a really awesome, efficient way of preventing repetition when you have these types of objects where you'll have just in the real world often thousands, if not hundreds of thousands of these same types of objects being created. Instead of hard coding them every single time, you can create this template of a class. So that's what we talked about last Thursday. Really important topic, especially for object-oriented programming. But let's go ahead and put it aside and move on to callback functions. So totally new topic. All right. So one moment. Okay. All right. So over here, I have 3 different functions. There's a greeting, a sorrow, and a celebration. These are all 3 different exclamations. And let's just take a little minute to talk about functions themselves before we jump into callback functions, because callback functions are very critical but can be very confusing. So we want to make sure we have our foundation all in place. So what I like to say what I think is the most important question to ask yourself when you're dealing with a JavaScript function is, what is the input and what is the output? So all 3 of these functions don't actually have any input or any output. So input, always you check the parentheses, and if there are any arguments, those are the input. Output will always be notable because there'll be a return statement at the end. So these things don't have input or output. And really the only thing you could do with a non-input, non-output function is console log, which is what these are doing. So they're maybe not that interesting. But if you had another function called, say, name, and it took in name, and then we console logged hello, and let's go ahead and run that function just to show you what it's like. I'll say hi to myself. So the say name function has one piece of input, the string called name. But notice it has no return value, which means it has no true output. And this is a confusing but subtle point, which is that Console log isn't truly an output. Nothing's being spit back out of the function. It's just a behavior that appears on the console. It prints a message for programmers to see, but it's not really spitting something back out. Whereas if we actually returned this string, now instead of console logging it, say name is returning out this hello and then whatever name. So if we say hello to someone named Joe, notice nothing appears to the console, but we can go ahead and log this new variable. So just a little bit of a review of functions. So this idea of input and output is going to be really important when we're talking about callback functions. So I wanted you guys to keep this in the back of your mind. Okay, so let's get back to our exclamations. So, so what is a callback? A callback is when you essentially pass another function into a function. So things are getting really meta here. We have this phrase in JavaScript called higher order function. And that just refers to the fact that while you could have a string as the input for a function, as we saw with that example I just did, you can also have a function that's passed into a function. And that sounds really weird, I know, and it is really confusing when you first see it. But let me show you a super simple example that'll hopefully clarify what I mean a little bit. So I'm going to create a higher order function. And I'm just going to call it callback example. And so this is going to have one argument, one piece of input, and it's going to be a function. And so it's often, callback functions are usually named callback or CB for short. So that's a convention that is used all over the place. So it's good to just get used to it. So when you see a CB as an argument, that means that we're dealing with a higher order function, and it expects some sort of input that is a function. So let's have the callback example. First console log, this is a callback example. Very exciting. And then we're going to call that function. So CB is a function name. And as we've seen with methods, with functions, whenever you want to call it, you always just throw parentheses. It's the same thing, whether it's coming in as an argument in a function or as just a regular function floating off by itself, you always use the double parentheses to call it. So let's look at how this works. So callback example, and we could feed in any of these three functions up here as an argument. So I'll do greeting first. Cool. So our callback example first says the phrase, this is a callback example, and then it greets us. What happens if we put sorrow instead? Once again, we get that first console log, but then we get our woe is me log afterwards. And as you might expect, if we change our argument to celebration, our second log is the hooray. So when we call callback example, of course, we will always run this line of code that prints the this is a callback example line. But then whatever is logged next is going to be variable depending on what I plug in. And another important thing to note syntax-wise is that when I put this callback function in as an argument, I'm just putting the variable name. I wouldn't actually call it. This is going to break things. So that didn't work. So make sure that when you're passing in a function as an argument to another function, you always just pass the variable name in. That's a really common mistake for people who are just starting with higher order functions. So as I always say with syntax, it's not the most important thing for you to learn. You'll get it with repetition, but right now we're focusing on just understanding conceptually what's going on. And this is definitely a little conceptually mind-boggling. So once again, we have a function, and then we put another function in as an argument. So why would we want to do this apart from making your lives more difficult with confusing stuff? Well, as you kind of saw here, there's some versatility. So we were able to change the behavior of this callback example just by plugging in a different variable. So that's, oops. So that's really easy to just change one variable name, right? And imagine that this were actually a much larger code base. These greeting, sorrow, celebration functions could be used all over the place in all sorts of other different higher order functions. So it really ends up saving a lot of time and space when you program this way. It can be very dry. That was something we talked about a lot with classes, is we don't want to do any extra work. We don't have to. So by being able to pass in functions, we could just have one copy of this celebration that exists somewhere in our code base. And then every time we need to use it, we pass it in. Another reason that callbacks are really critical is asynchronous programming. So asynchronous programming is not a topic we're going to get to in this mini bootcamp, though we absolutely cover it in our full course. But asynchronous program is essentially what makes backend JavaScript possible. It's a tool that backend JavaScript uses to make sure that we can do lots of complicated things and do them quickly. Because when we're talking about web development, the page load is one of the #1 things we're focused on. So once again, we're not going to go into what asynchronous programming looks like in this, but just know that this type of callback use is going to be critical when you start to learn that. So we're laying the foundation for that right now. The last reason that we would want to do something like this is there's a style of programming called functional programming, which essentially means that everything is a function. When you get into functional programming, callbacks become key. So we're not going to talk about functional programming anymore today, though we'll see a little bit of it tomorrow. But I wanted to make you aware that this tool, this being able to use higher order functions and use callbacks, is really critical if you want to get into functional programming, which is a very popular style of programming that I personally happen to be a really big fan of. So hopefully I've convinced you that this crazy thing of passing functions into functions is actually extremely useful, because now we're going to dive in even deeper. So let's go ahead and look at another example. So over here, I've written a function called complement. And this one console logs as well, but we have a input. So to run complement, I just throw in a name. And oh, look, the console just told me that I'm a wonderful human being. How lovely. So we have a complement function. And now let's imagine that we wanted to use it in some other context. So say we had some function going on here. And we had some sort of name available to us. I'll make it Stephen. So in give feedback, we're going to say something to Stephen. So of course, we could just call complement, right? It exists in this outside scope. So we could just call complement, throw in that name variable, and then when we run give feedback, it goes ahead and runs complement. So that's kind of what we've seen already, is just calling a function in a function. We could make this even more versatile. Let's say if feedback actually takes the name in as an argument. Now we can change just with this variable very easily who's getting the complement. So that's nice, except it's not very functional and it's not a higher order function. So the complement is hard-coded in here, but what if we wanted, once again, some versatility? So we could actually have a callback here and do this instead. So on the surface, this has the exact same result, right? We just were able to complement Alice really easily. Instead of actually hard coding in complement, we've gone ahead and passed it in as a callback. But the way that I've changed this, the fact that I've changed this into a higher order function actually makes this give feedback function much more subtle. Because now we're not committed to just complimenting Alice. We can say whatever we want to her. So what if we had an insult function as well? Maybe we also want to insult Alice because, Alice is a jerk sometimes. So now I have this insult function. It works pretty similar to the compliment in that it takes in a name and then it spits out an insult and personalizes it to whoever's name is there. So now we're able to use give feedback to compliment Alice, but we can also use it to insult her. And of course, we're also welcome to tweak this name. I hope there are no Alice's or Joseph's in the audience tonight, in which case I apologize for the harsh words that the console is spitting out here. So this is great because we're able to just toggle between whichever behavior we want with one variable change. And as I mentioned in the last example, maybe these insult and compliment functions are being used all over the code base for different things. And in that way, we can just have one copy of them that we pass into this higher order function and really easily toggle what our feedback is. All right, I want to show you one more example. So what we've been doing here is we've been writing out the actual function, the insult or compliment up here, and then we pass in the variable name. But if you want, you can write your function directly in the call. So we could do an anonymous function here, takes in a name, and maybe we want some sort of neutral feedback. So now we're using give feedback to give this neutral feedback to Joseph. But instead of having up here a function called neutral comment, maybe, we're just dropping the anonymous function right in. So both of these are acceptable ways to use a higher order function. I'm personally a fan of actually writing out the function separately. I think it's more readable. And in that way, if you ever want to reuse the code, it's ready for you. But there are contexts when it's nice to be able to just drop in an anonymous unnamed function. So I'm going to go over that throughout the rest of the lesson, that there are these two ways to do it, because you'll see both ways. And I don't want you to panic when you see this disembodied anonymous function floating in an argument call. So once again, the syntax can be a little weird on this, but it really is just an anonymous function dropped into a function call. And if you forget exactly where all the parentheses and commas go, this video will be up online. You can also do lots of Googling and see another example. All right, so let me talk a little bit here. I'll move our neutral comment up here with the others. And then let's change it to that other style. Okay, so that still works. So let's talk a little bit more about input-output. When I was reviewing functions, I mentioned that that is a very important lens to see these through. And we have to think about it on two different levels, right? There is our higher order function, give feedback, and then there are our callback functions, these three up here. So give feedback has two arguments, name, which is a string, and callback, which is going to be a callback function. And then the callback functions themselves only have one argument, which is this name. And notice that all three of these are of the same form, right? They all take in a name, they all take in the string, they all console log something, and then none of them have a return value. So that's really important. When you're swapping out these functions in here, they all have to be of the same form or else it's not going to work. So for example, if I had some other callback that took in two variables and just console.logged the result of them being added together, this is going to be a little confusing because give feedback expects a callback with just one input, a string, not two inputs that appear to probably be numbers. So keep that in mind when you're writing these, that all the callbacks need to be of the same form, or else you're essentially going to have a compatibility issue. So I've mentioned return statements a few times, but we haven't actually seen any callbacks with return statements. So I want to do another example where we have some return values. And hopefully I'm not throwing too much at you. I wanted to give you a lot of different examples of ways that this can function, because I know this can be really confusing. So if nothing else, I want to prove to you how useful it is. So here's a couple little math callbacks. So we have our first function called increment. It takes in a number and just returns that number plus one. Triple, triples the number. Half, halves the number. So these are nice, neat little callbacks, and notice that they all take in one number and they all return one number. So they're all of the same form, which is always a good sign. So let's see. If we went ahead and created another function called, we'll call this one do math, and it is going to take in a number. And first do math console logs, we're doing math. Very astute. And then I want a callback here. That's not going to be very interesting otherwise. So then we go ahead and run our callback on whatever number was inputted. So what we're doing with this higher order function is we're essentially just running the original function, but with this additional behavior of this log statement that tells us that we're doing math. So in that way, with just a few lines of code, we're able to add this console log to any callback of this form that we want. So if we do, and we want a return statement. So let's throw in 5 and let's increment 5. So because do math has a return statement, we know that there is going to be an output, a result of some sort. Oops. So we run this, and of course, we first, inside the function, run, we're doing math. But then we return the result, and we're able to actually console log that. So we can, and as we saw with all the other examples, we can change this to half. You can change it to triple. And we're able to fundamentally change this behavior by only swapping out variable names. And as a final reminder, if we had some other function called add, and let's say this returns the two numbers added together, we would not be able to use this callback function because these three are of the same format. They just have one input, whereas add has two. So if we tried to throw add in here, we actually get not a number because it was trying to add a number with an argument that was non-existent. So really important that we think about how all of our callback functions need to be of the same format. Whereas our higher order function is kind of doing its own thing. It's just utilizing the callback. So if and as a reminder with the return statements, if our callbacks have return statements, then we also need to return the result of that out. So let's take a deep breath. This is a lot of stuff. We don't expect you to fully understand this, but it's extremely powerful and it's extremely critical. So we really do want to introduce you to these advanced JavaScript topics so you can start to play with them, start to get a hang of them. Okay, so this concludes the basics of callback functions. So now we're going to move on to one of the most important use cases of callback functions, which are array methods. So I'll go ahead and bust out a whole new example for this one. So let's say that we have an array of numbers. And we'll go ahead and use our triple function that we just saw. So this takes in a number and it returns, actually, we'll use triple in a minute, but first let's just do, let's just do a log. Sorry, bear with me, guys. Okay, so we have an array of numbers. And say that we want to print all these out. This is something that we've done before when we were going over loops and arrays. So if we want to print everything out of our array, of course, we're going to need a loop. So we could write our, hopefully starting to get familiar, for loop. Numbers.length. And then as we go through, we could console log numbers at whatever index our loop is currently on. And there we go. So we loop through, we console log every single number in here. And if you guys have been practicing for loops, you're probably getting really sick of writing this line of code. I know that I certainly don't like to do it. Luckily, that there is an easier way. It just requires understanding callbacks to use. But now you guys are ready to jump in. So what's really cool about arrays is that they have a bunch of built-in higher order methods. So there are these really common things that we end up doing with arrays a lot. We end up iterating through and doing some sort of behavior, like we just saw with console log. That's really common. We also might want to alter the values of the array in some consistent way. And finally, sometimes we want to take all the values of an array and combine them in some meaningful way. And so we're going to talk about 3 different higher order methods on arrays that allow us to do this really easily. The first one is called for each. So if we do numbers.forEach, we can then put a function inside here that tells us what to do with those. So let's look at the syntax here. We have numbers, which is our array name, and then .forEach, which .forEach, which is our method call. And then inside of our method, I've went ahead and put an anonymous function. And so this function just has one argument, the item, which is going to refer to each item in the array as we go through. And then we can tell it to do whatever we want with those items. So as it turns out, I just want a console log. So I don't actually need this whole anonymous function. I can just do console.log. And keep in mind that console.log is a function, and it's a function that takes in one argument. So that's going to be the correct syntax for this. So let me comment out my for loop. Uh-oh. That's not doing what I want. 1 second. Each item. Try doing it this way. There we go. I wonder if it's something weird with how Replit processes the array, because that's not normally what happens. But anyways, so what we've done is we've said for every item in this array, we want this behavior on each individual item. We want to log it. But we could change this. For example, let's say we wanted to log the negative version of the item instead of just logging it. So now instead of throwing our item in, which we know is a number, I went ahead and added a negative sign. So that's cool. We've not only logged every item in here, but we were able to alter it in a little bit. What we could do instead is do item plus 5. And in that way, we're able to really easily alter the behavior of this, of what's going on here. So Instead of having to write out all of the syntax of the for loop, we're able to just use for each, and then we drop in this anonymous function, which tells us what we want to do to every single item in the array. So that is our for each loop. The next array method I want to show you is map. So notice that for each doesn't have a return value. It doesn't give us a new array. It just does something with the current array. In this case, we were just logging. And oftentimes in your basic examples of for each, you're just going to be using console logs. The real world cases get a little more subtle. But mapping actually creates a new array. So if we wanted, instead of just to log the negative version of everything in here, maybe we want to create a whole new array where everything is negative. Well, we can do that with map. So I'll comment that out and show you guys map. So once again, really similar syntax. We have our array and then .map, which is the name of our method. And then in the parentheses, we can go ahead and drop an anonymous function. So this function is going to be very similar to the one for each. There's just one argument, the item, but the map function needs a return value. So instead of logging the item, we're just going to return the negative version. So whenever we use map, we use an anonymous function or a named function that we wrote elsewhere. And that function has one argument, and it always has a return value. And then this whole thing will spit out a new array. And that way we've mapped our original array to some alternate universe version where everything is negative. And we can do other things here. You know, we could divide these by 2. And once again, we've created this. And let me just, for proof of concept, let me log the original array as well. So our original array is untouched, and our new array has been mapped as according to our rule. And let me just go ahead and grab this triple function from over here. Just as a reminder, we don't have to write an anonymous function in here. We could use an existing function name like triple. And we know triple is going to work because it takes in one value and it has a return statement. And once again, we're able to map this new array to a tripled version of our original array. So that was for each and map. For each just executes some line of code on every item in the array. Map actually creates a new array where all the items have been changed in some way. The last one I want to talk about tonight is reduce. And reduce is kind of a doozy. So reduce is the function that we use when we have an array and we want to combine all of the values in the array into something new. So let me just get rid of all this code so we can start fresh. So we have this numbers array, and we can think of a few examples of times we might want to take all the values in it and somehow refine them down to one output. So for example, if we wanted to add everything in this array, the result would be just one number. If we wanted to multiply everything in this array, the result would be one number. Once again, if we wanted to, say, find the maximum value or the minimum value, once again, we're taking a collection and reducing it down to one item. So that is how you know that you need to use reduce, is if you have a collection and you somehow need to distill that down to one value. So before I show you how to use reduce, let's go ahead and write a reduction piece of code just from scratch, because that'll help us think about what actually goes into this. So I will use the add example. So if we wanted to add all these guys up, we would probably create some sort of variable called sum so far. Let's start that at 0. And that'll help us keep track of how much we've added up as we went. Then we want our for loop. And then what we can do is we can go ahead and to sum so far plus equals numbers at I. Just as a reminder, plus equals means we're taking this value and we're adding it to whatever's here and sticking it back in that variable. So, and I will go ahead and actually console log our sum so far because that'll help us see the results. And then at the end, we can create something called sum, and it'll just be equal to our sum so far. So, and final result. Okay, so we're looping through all these numbers. As we grab each one, we're going to go ahead and add it to this variable. Oh, wait, we don't want that to be a const. That won't help us out at all. All right. And then at the very end, we'll go ahead and save this into a final result. So let's run that. So we start with 0, then we add in that 1, we add in the 6, the 3, the 8, and finally the 9. And we get a final result of 30. So the critical pieces, it seemed, to doing this kind of accumulation logic were we had to have some sort of variable to keep track of where we were at in the process. And then we had to have some sort of loop that allowed us to work with whatever item in the list we were on. And this is exactly what goes on behind the scenes in Reduce. So if Reduce is seeming overwhelming to you, I would recommend coming back and checking out this because sometimes kind of seeing under the hood demystifies it a little. But fortunately, they've done all this work for you. So once you learn how to use Reduce, it can be extremely useful. So let's go ahead and actually use that built-in Reduce method to do something very similar to this. So I'll leave this up here in case we want to refer to it. But let's do numbers.reduce. So the same syntax we've been seeing. We have our array, we have .reduce, which is the name of our method, and then we plop an anonymous function in here. Now, for each and map only had one argument in our callback, which was the item. And that helped us keep track of where in the array we were at. But reduce requires another argument, which is usually called the accumulator. The accumulator is what we did with the sum so far. So the accumulator is kind of our progress so far, whereas the item is literally which item in the array are we on right now. So with our, if we're trying to sum up the array like we just did, we would just take our accumulator, which is like our sum so far. We want to add that to whatever item we're currently on, and we want to make sure we return it. So just like map, the reduce anonymous function always has a return value. And this is telling the function, this is our new accumulator. We want to take whatever the sum was, add the new item, and then return it out to be the new accumulator. And of course, reduce creates an output of one number, so a result. So let's see how we've reduced this. Cool, 30. That's exactly the same value we got when we broke it down here. So I'm feeling pretty good about that. Let's look at just a few more ways we might reduce. So I had mentioned that we could also multiply every value in the array together. That would be extremely easy to do given our code. We just changed that to a multiply symbol. Now we've multiplied all these values together. Let's just double check our logic. 1 times 6, probably didn't need to do the 1 times 8 times 3 times 9. Yep, that's cool. Let me show you a max value example. That's a really common use of this. So in the max value, we really just care about, is the accumulator bigger or is the item bigger? Because if the accumulator will be the biggest thing we've seen so far. So at the beginning, it would just be 1, then it would be 6. Over here, it would still be 6. Now it would up to 8, still be 8, and then finally 9 would override it because we're just seeing what's the biggest so far. And then when we get through the whole array, we found the ultra biggest. So you might not have seen this before, but there's actually a built-in max function just built into JavaScript called math.max. And we can see what is bigger out of the accumulator, which is the largest number we found so far, versus whatever item we're currently on. Cool. And let's alter this array a little bit to make sure. We're still getting 9, so that's a pretty good sign. The last little tidbit I want to show you with reduce is that you can put in an optional start value. So up here for our max example, we're just finding whatever is the max value in the array. But let's say that you wanted either the max value in the array or 10 if nothing's bigger than 10. So you put in a starting value of 10. But if you said, put in a starting value of 5, we still get the result of 9 because there's something bigger than 5 in there. Same thing with the sum example. If we wanted to sum array, but also throw in a 100 for some reason, let's change this back to our sum code. Now we've taken the sum of this array plus 100. So once again, the starting value is an optional argument. If it's left out, it'll just use the first item in the array to start. But that's a nice little piece of versatility, because I found using reduce in the real world that sometimes a starting value is really useful, sometimes it's not. So it's great that we have the option to do it either way. So reduce, map for each, really critical, especially map and reduce are used all the time. I actually used to work in data aggregation and analytics before I came here to Lambda School, and we would use this so much. It was so critical, and it made the logic a million times easier to write. So like with a lot of new things that you learn, what can seem a little syntactically hairy or conceptually strange at the beginning ends up being this extremely valuable tool. So I would really take the time to understand and get good at these higher order functions, because they're really frustrating until all of a sudden you feel like a programming wizard because you can do everything so quickly with reduce. So that is all the new material that we're going to present tonight. I just wanted to do a little recap of everything we learned tonight. We talked about higher order functions, which simply put means passing a function into a function. So we just take a function, call it within another function, and then we can go ahead and very easily change the behavior of the higher order function with just a tweak to the variable name. So we talked about callbacks and higher order functions, and then we saw a really cool example of one of the most common ways this is used with our array methods. So once again, those were for each, which just iterates through, map, which actually creates a new copy of an array that's somehow been mutated, and reduce, which takes a group of items and distills them down to one. So that is it for tonight. We have an assignment for you on GitHub, as usual, so you can practice some of this crazy magic. But I do have about 10 minutes left, so why don't you guys go ahead and ask me any questions you have. Hopefully your brains aren't too broken, and I'd love to get your questions in Slack and address anything that I can to help clarify this material. Is everyone's brain too broken? It's only Monday, guys. All right, well, it does not look like we have any questions then, but as always, we will be, oh, someone is typing. A couple of people are typing. While we're waiting for them, I will say that we're always available in Slack. As you're rewatching these videos, working on the assignment, if you're not watching this video in real time, go ahead and get on our Slack and ask us some questions. Okay, so Kevin asked, could you clarify function as an argument? Sure, let me go ahead and clear this, and I'll go over that again. So let's just talk about what an argument is in the general sense. So if we have function do stuff, so let's say that this is just some sort of math related item. So we have these two arguments and their numbers, and inside the function we manipulate them. In this case, I'm going to add them together, and then maybe we want to return the value. So let's actually run do stuff 5 and 7. So we run it and we add them together. Maybe instead of adding them, we wanted to console log them instead. That works too. So this isn't a higher order function. This is a regular function. We just taken these two arguments that happen to be numbers and we do some stuff with them. It could be a number and a string. It could be a number and an array. But the idea that we introduced tonight that's a little wild is that we could take in a number and instead an actual function as an argument. So we're passing the function into this do stuff function. And just like any other argument, all that means is we can manipulate this function however we want in here. So if we wanted to, and of course, the only real interesting thing you can do with a function is call it. So actually, let's call this func. Here's our callback, and we're going to go ahead and pass the number in there. So now we can actually call do stuff. We know the first argument's a number, let's say 4, and then we need some sort of function. So we could do console.log. So what do stuff is going to do is it's going to run console.log on the first argument. And in fact, we don't even need this to be a number. It could be a string as well. So all we're doing is we're passing in a function that we can call later at our leisure within the actual function. So hopefully that clarified it a little bit. I will say, though, that it's probably not going to fully make sense until you just practice with it. So our next question was, is it common to have widely used functions tagged in the code or saved in separate files? Yeah, so usually you would, I mean, it really depends, but one thing that I often do in code bases is I have some sort of utility file. So an example, as I mentioned, I used to work in data aggregation. So an example might be that there's all these common utilities that we do to our data. Like one would be processing dates. We would, in our data collection, we would get in values like a string that's like August 12, 2018, which our database doesn't know what that is. That's just a string. So we'd have some sort of utility function called process date, and it takes in a date string and actually returns a date object. So a date object has all these built-in useful, it's an actual timestamp that tells us when this date is, whereas a date string is just a string that's human readable but not computer useful. So we would use this process date logic everywhere. So we had it in a utility file separately, which in Node, you're able to import in other files pretty easily. So in that way, we could, whenever we had another file where we wanted to process a date, we just import in our utilities and we could run, util.processDate. So any other common, another common thing is we would go through and we'd scrub data. So we'd have like a function called scrub, which would take in data. And so if we got in a string, like if we had in an input that was something like a space, and then a number, those spaces shouldn't be there. We'd just return the 5 on its own. So these things were used all over the code base. So instead of rewriting them all the time, we could just import in a util file and use them wherever we needed them. Okay, and then we also had a question that was, what is the difference between an argument and a parameter? And it looks like that was already replied to on Slack, but I'm going to answer it anyways here. So it's essentially, it's just, are you looking in or are you looking out? So if I'm using Scrub, I pass in an argument like this annoying string that has a bunch of spaces in it. But if I'm writing Scrub, I would normally refer to it as the parameter. That is technically the correct use of the two. You will often, just in passing, hear them interchanged. I probably am guilty of it myself, and I apologize for that. But it's good to know what the technical correct usage of each is. So, all right. Does anyone else have any questions before we call it for tonight? Okay, I guess it's time for me to set you guys free to write your own higher order functions. So good luck with the homework tonight. Definitely use all of the resources available on Slack if you have any questions. And I will see you guys tomorrow for some more JavaScript fun times. All right, thank you guys for watching. Have a good rest of your evening.